Okay, so the next problem in the lead code we are solving is generate parenthesis. Okay, basically here they have given us a n, and we'll have to generate a combination for it. Okay, like I mean n meaning like I mean number of open parentheses and number of closed parentheses count. Okay, total length would be 6. Okay, like let's say before actually going to this generate parenthesis, we should be aware of what is valid parenthesis, right? Like I mean meaning like I mean like we are not supposed to have more closed brackets, right? Let's say that this is valid, correct? Like we have a correct corresponding closing bracket and open bracket for each one. Okay, let's say that I have this one and I have one more this one, right? It does not have corresponding open bracket for it, correct? Like I mean this is matched, but this is not, doesn't match with anyone, so this is not a valid parenthesis. Okay, that's a basic actually. So we should be aware of it. And next thing is and also like I mean yeah, to keep it simpler, we should be like what we can say is always like I mean if in a valid parenthesis, right, it should be open count should be equal to the close count. Okay, so now let's see like what does this problem actually mean, and how we are going to approach this problem. Okay, so basically what they're asking is like for a different value of n, like I mean n represents the number of open parenthesis count or number of closed parenthesis count here. Okay, and for a given number of n we'll have to try out the different number of combinations here, correct? So let's say that if n is equal to 1, right? So basically open parenthesis is 1, close parenthesis 1, like we are done, right? It cannot be like I mean we cannot write more than one combination for it, right? So now let's say that n is equal to 2, and if for an n is equal to 2, what we can do is, so the combination would go like this, right? Like I mean I can do it, I can write it like this one. Okay, or else simply I can, what I can write is I can open all of them and I can close all of them, right? This will be the combination, like 2 combination for n is equal to 2. Similarly I can write it for n is equal to 3 also, right? N is equal to 3 also we can write it, right? Like I mean this is the problem it's about. So basically for what we are going to do here is like I mean let's say that if I want to write a combination for this one, I can open everything and close everything. This is one valid combination, correct? So next what I will do is I will open only 2. Okay, open only 2 and I will close this first and then open again, right? Yeah, like I mean this kind of combinations, right? Like this kind of combination that we are need to come up with, and we'll have to give return it as a result. Okay, actually there will be till more number of combination to go, where I will just stop it here. Okay, now let's check the code how to go about it. So basically the okay, before one more thing is basically like I mean what are we trying to do here is like we are trying to build a combinations, right? Whenever it's a combination, backtracking is the way to go here, right? Like I mean we are going to build a kind of backtracking, meaning like we can generate a different number of combinations here basically. So why does it so, like because like I mean in the backtracking, right, let's say that if I'm in a graph or something, I'm going to going from start to end, correct? And I can go from n number of ways, right? I can go here and I can see like if something is not working, I can go back and go here, or I can like I can search for something. If it is found, I can go and check for something else. All these things we can do. So backtracking will be the way to go to find the combinations. Okay, and so backtracking meaning it's nothing but a recursive, right? We will be writing a recursive function here to generate a different number of combinations. Okay, and when writing a backtracking algorithm, one thing to keep in mind here is we'll also have we'll need to tell the child recursive function that what you have done so far, so that the child recursive call can use it to build on top of it. Okay, so basically like when I say I'm going to some a to z location, right? I have there is a different cities. Okay, and if I tell this city like how I have traversed before, right, on top of it, it will build the remaining part, right? So that's how this backtracking algorithm works. So once it got some result, it may be valid or invalid, it will come back and it will try different things, but this should be given to the child recursive calls. Okay, now let's see that how we are going to write it. So basically as we discussed, right, so we are going to use a backtracking mechanism here which will have a recursive function, like it's a nothing but a recursive function. We are solving it via recursion. Okay, and we are going to send the whatever so far we have built, right, we are going to send it to the child function, right, that we are going to take it as an argument. S is nothing but a string, like okay, that we have built so far. Like here nothing but we are building the list of strings, right? So whatever so far we built, we will have to send it to the next call. Okay, so when you start, you will have nothing, like I mean we have not built anything, and also we'll also keeping track of how many number of open bracket and open how many number of close bracket. Okay, actually before actually going to this, let's discuss the end case, right? Like what will be our backtracking should also have an end case, that also we missed here. So basically when you say backtracking, like you should have an end case also, correct? And also it's a recursion, nothing but, right? So either you can say, simply say, like if the string length is equal to 6, right, that's a, that we are good, correct, that also can be done. But it can be having a like miss faults here, like let's say that I opened all of them as open bracket, right, that's the invalid string, we are not supposed to consider that, correct. So basically we'll keep a track of the how many number of open counts are there, how many number of close counts are there at the end. Like after we built it, right, we need to do the comparison, like at the end we need some decision, right. So here in the backtracking, okay, we to consider it's a valid, we need something. So here that something will be equal to the tracking of this one. Okay, this is the recursive function. What we'll do is we'll keep a track of how many number of open counts are there, how many close brackets are there. If it once it is equal to that, right, we'll be considering that as a, okay, we got a result, we'll add it to the result and we'll come back to the next iteration. Okay, we'll step back or to one step back and we'll be trying the different combination basically. Okay, so when we start it, initially you will not have any open count or close count, correct, like I mean, you will not have any open parenthesis or close parenthesis. And also the combination you've done so far is also an empty. Okay, we'll send it to the backtracking function for the first time. Okay, so here it will start building the remaining combination based out of it one. Okay, so what we are going to do here is, the main condition is, this is the exit condition. Okay, like every recursive function should have an exit condition, that is a must, or else will be resulting in an endless thing. Okay, so what is the one thing we are going to do here is the two condition basically. So if you don't have any, if the open count is lesser than the n, right, let's say that if I have not opened any open bracket yet, so we are going to add the open bracket. Okay, so we'll, how does we do, like when how we are going to track it is, let's say that if I'm going to open a new bracket, I'm going to increment the count, and I'm not going to update in the main call, like this is the parent call, right. In the parent call, open count should always be 0, like it should not be 1, right. This count is for the next call, right. So that's why we are going to update it in line. Okay, open count will be incremented, and close count, we have not added any close parenthesis, so close count remains the same. Okay, and for the child call, it will be a new string for them, correct. Yes, plus we are opened the open parenthesis. Initially it was empty, here we are going to add one more parenthesis. Okay, similarly we will be going to do again and again. So ultimately how it will look is, let me clear this out. Okay, so how it will look like, firstly when we'll open all the like if the count is less than 3, right, we have opened everything, and then once we are done with this, we are not no more going to add it, because it will cross the this one, right, like the open count is done. So now all the recursive call, like what are the next recursive call will do, close count is lesser than open count, we are not supposed to open, we are not, it's not less than n, right. Let's say that if the open count is 2, okay, open count is 2, we are not supposed to close it by a 3, like, because if we do it less than n, right, we are end up closing 3. So we always have to make sure that we don't close more than the open count, like open brackets are only 2, we are supposed to close only 2, like we are not closing more than that. So that's why this condition is essential, close count is will not cross this one. Okay, so we'll open the bracket and we'll close it here. Okay, wherever we close, we need to make sure to set tell the child recursive call that we are incrementing the close count, and whenever we open, we will do this, and we'll have to send the path to them, like I mean, so far what is being done. Okay, so finally, like I mean, we are going to build a recursion out of it, and yeah, once we reach the end condition, right, we'll be adding the result, we'll be sending back. Okay, actually for better visualization, you can use this site python tutor visualization. Okay, now let's quickly see how we're going to do it. Okay, so let's say that we call this function, and we'll come back here first. So initially we have nothing, like this is empty and open count is 0, this is 0. Okay, so now what will happen, there is nothing to exit condition is not yet met, so we'll go here. So here what will happen, it is still less than n, right, open count is still less than n, so we'll add a open bracket and we'll call it back. Okay, so again we'll add because still it is less than n, right, like I mean, open count is still 1, it is less than 3, so we'll go it, add one more, add one more. So this time it is 3 already, it is not less than then some. This time what we'll do is we'll start closing it. So this is the, like you should understand like how this stack is working. Okay, so we have opened it, and finally this, once this is done, right, this condition won't execute, and last call will execute, like I mean, this will execute. Now we start closing everything. Okay, okay, now, yeah, like once this is done, right, okay, let's say that we'll go to one more step. Okay, now this is done. So now when it comes here, right, this condition will be matched in that child call, so result will be added. So you can see result is added, result got updated. Okay, and now what will happen, there is nothing left here, right, so everything recursive, it will go back till here actually. So it will go back till here. like I mean there is nothing, no code left to execute, so it will be coming back now. So let me see. Okay, it is done. Done, done, done. Okay, so but when there was a two open parenthesis bracket, right, we have still left, we haven't executed this part of the code, so that's why this will execute. So previously what happened, like I mean three executed, right, like once this was run, so all this code was executed in the recursive time, right? Like when n was 2, we didn't execute this part, there is something still left to execute, that will start executing now. Like I mean it will close this one, and in the next iteration call it will open the bracket again. Let's see. This one open, should open it. Yeah, it should do to open it. Okay, so simply I think it's better you just play around with this so that it will get a more clear understanding that how gendered parenthesis is working. So just to give a summary here, how did we end up in this logic? So basically here we are trying to generate a combination, so that's why we are using a backtracking algorithm. So backtracking is nothing but a recursive function, correct? For every recursive function we need a exit condition that we need to understand. So exit condition is nothing but to either we can rely on the length actually, but that might give us a false result. Like so we are keeping track of open count, close count, and if it is equal to n, if that is the case, we'll be considering that as a result. Okay, so that was the exit condition. This is the same thing for all the combinations or all the recursive functions. This is going to go, this is what going to do. And also when we say backtracking, we should be sending the child notes that what we have done so far, right? So that's why we are going to send a string here, like whatever we built so far, and this is how we are going to send, like whatever we have done, right, we are going to send a modify the inline modification and tell the child that this is what is done so far. Okay, and here what we are making sure for this particular problem is, what is the change here is, we are making sure that we are not opening the brackets more than the given count, and also we are ensuring that close count will not execute the number of open counts. Yeah, that's it. Thanks.